Well, welcome to C2GTalk, a series of one-on-one interviews with influential practitioners and thought leaders to explore some of the governance challenges raised by emerging approaches to alter the climate. I'm Mark Turner, Senior Communications Consultant with C2G, and I'm speaking today with Paulo Artaxo, Professor of Environmental Physics at the University of Sao Paulo, and one of Brazil's most influential and prolific scientists with a focus on climate change and air pollution. Professor Artaxo is a member of the Brazilian and the World Academy of Sciences and has worked with the IPCC for around 4 decades. He's gained particular recognition for his work on the Amazon. Paulo Artaxo, welcome to C2GTalk.
Hi, Marcus. Thank you very much for the invitation to talk here with the C2G. It's my pleasure to do so.
Well, thank you. So let's dive into it. You recently attended the COP27 Climate Summit, I understand. Commentators have welcomed a deal on loss and damage there, but expressed quite a lot of disappointment at the lack of strengthened commitments to reduce CO2 emissions. How would you describe the outcome of that meeting and basically the state of climate diplomacy right now?
Basically, yeah, I was the whole time during the COP27 in Sharm el-Sheikh, and basically everyone who left the meeting was very disappointed. Let's say this, I cannot find a single person who left the meeting with the optimism. Basically, by several reasons. The first one is that the final official communication documents from the COP27 even does not mention that we have to phase out fossil fuel. It even does not mention a clear mechanism for loss and damage, as you mentioned, and does not really make any significant contribution on reduction of greenhouse gas emissions. So basically, we are going to a planet that is about 3 degrees hotter than pre-industrial values. So this will bring tremendous impacts on our society, both economic and also social. And certainly we are in the wrong track to build up a sustainable society. So that was the reason of my disappointment after COP27.
Right, but 3 degrees, that's a high, quite a high. What makes you think that we're heading for 3 degrees at the moment?
Actually, it's not myself who thinks that. Right. You know, Nature have done an interview with the hundreds of climate modelers just after the AR6 from IPCC was released. And there is a paper in Nature, November 2021, that Nature make a single question to hundreds of climate scientists. Which is your best guess of how much will be the increase in temperature along this century? And of course, the answers vary significantly in between 2 to 4.5 degrees. And the most, let's say, the average result is 3 degrees. Wow. And actually, if you fulfill all the Paris Agreement expected reduction in greenhouse gas emissions, we will heat up the planet by 2.6 degrees. But as we know very well, most of the countries will not fulfill their commitments on the NEDC associated to the Paris Agreement. So basically, we are going to, in average, 3 degrees, that in continental areas means an increase of about 4 to 4.2 degrees. In cities where 80% of the population will be lived in 2050, with the increase in the urban heat island, this means an increase in temperature somewhat in between 4.5 to 5 degrees. So this is what our economic system is driving the planet right now, and certainly we need clear action to avoid this kind of scenario.
Wow. That's a sobering assessment. So one bit of progress that people sometimes point to is that a growing number of countries have committed themselves to net zero by a certain year. Is that actually possible?
Yeah, that's a very good point. Because, for instance, the European Union wants to become net zero in 2035, the United States 2040, Brazil 2050, China in 2060, India in 2070. But the problem is, right now, production of food is responsible for 30% of the global greenhouse gas emissions. How, with a growing population and billions of people that has very little food in developing countries, the demand for food will increase. So right now we have 30% of the emissions by the food chain production. So how are we gonna mitigate this? How are we gonna to compensate for 30% of the total greenhouse gas emissions today? So that is, in my opinion, is basically an impossible task. So food production is the major challenge we will have in terms of reducing emissions. We can change the energy system to stop burning fossil fuel. That is easy. We have the technology for that. That is economically feasible in the next few decades. But the major challenge is actually food production for a growing 10 billion people in 2050. And we can try to reduce emissions, but it will be extremely difficult to get net zero as committed in the national determined contribution for most of the countries by 2030, 50, or 2070. So this, for me, is a major challenge for our society.
I understand you're recently back from, or still in, but Amazonia. One of the few highlights, I guess, of the COP27, at least from the reporting that I covered, was the speech by Brazilian President-elect Lula, who said Brazil's back and committed, to ending the destruction of the Amazon. At the same time, we saw a warning from WWF saying it's on the brink of a tipping point, becoming permanently degraded. And as far as I read, the Amazon's already become a net carbon emitter and has so since 2016 or so. But perhaps you could just summarize, how serious is the situation facing the Amazon right now, and what consequences would its continued destruction have for the global climate?
Yeah, a few weeks ago, the Brazilian government released the deforestation number for 2021 to 2022. And Brazil have deforested additional 11,300 square kilometers of primary forest. So it's a huge amount of carbon that is being released into the atmosphere without any benefit for the Brazilian or for the global society. So of course, the very first task that Brazil have to do is to get zero deforestation as quickly as possible. The commitment from the new government who will take office on January 1st is to zero deforestation by 2028. This is possible, and there is no cheaper, easier, or faster way to reduce greenhouse gas emissions than stop deforestation. Another important advancement is the joint efforts between Brazil, Indonesia, and Congo signing an agreement to jointly reduce tropical deforestation, because, of course, it is essential to stop deforestation in all tropical countries, not just in Amazonia. But, and there is a very important but, the problem is that the Amazonian forest, because of the increase in temperature, is suffering very important degradation and is starting to lose carbon to the global atmosphere. Why this is important? Because Amazonia itself, only the Brazilian Amazonia, holds 120 billion tons of carbon in the ecosystem. This is roughly 10 years of all fossil fuel burning in the whole planet. If a fraction of this carbon goes to the atmosphere due to the increase in temperature and the reduction in precipitation in Amazonia, then bye-bye to all of us. So basically, in addition to stop deforestation, it's absolutely essential to stop the burning of fossil fuels. Even if Brazil stops deforestation by 2028 to zero, if the developed countries continuing to burn in fossil fuel, the Amazonia and all the other tropical forests does not have a future, and the carbon that is stored on this critical ecosystem will be released to the atmosphere, aggravating the climate emergency that we have right now. So this is clearly the scenario I see in terms of global carbon emissions.
Is there any way of helping to protect the Amazon from that temperature increase? Is there forest management techniques that can basically avoid permanent degradation?
Mark, the only way to protect the forest, in addition to zero deforestation, is to reduce the greenhouse gas emissions. Because if we allow the global temperature to increase by 3 degrees, in Amazonia, that's a continental region, the increase in temperature will be about 4 degrees. What happens is that the enzymes who controls the photosynthetic process in Amazonian plants have evolved over the last million years to a certain temperature.
Right.
So they are optimized to make photosynthesis in a certain temperature. If you increase this temperature by 3 or 4 degrees, the enzymes does not work anymore properly as they were designed to do. And then we'll have photosynthesis reduced, and the carbon will go to the atmosphere. So basically, this is a process that already started.
Yeah.
This is not forecast for the future. Several recent studies using remote sensing techniques or using in situ measurements using aircraft in Amazonia shows clearly that the parts of the Amazon forest is already becoming a source of carbon to the global atmosphere due to increase in temperature and reduction of precipitation in the Amazon region caused by global warming.
Yes. Well, I wonder if we could switch to another of your areas of expertise, aerosols and air pollution and their impact on the climate. It's one of those aspects that is not probably widely known, the masking effect that aerosols have on the temperature. So perhaps you could explain a little bit about to what extent pollution, other aerosols are and how much they're masking global warming, and what kind of impact we might see from efforts to reduce air pollution.
Yeah, that is a very important issue. You know, in the atmosphere, you have 3 main ingredients. The first one are the trace gases: oxygen, nitrogen, and the greenhouse gases like CO2, methane, ozone, and so on. The second component is aerosol particles, particles that are suspended in the atmosphere. And the third components are the clouds. So basically, talking on the aerosol component, aerosols are small particles that have a size similar to the wavelength of the visible light. So they scatter radiation back to space, making a huge benefit to the climate system or of cooling down the surface temperature, scattering back radiation to the space, not letting the extra radiation reach the ground and increasing our temperature. Right now, the IPCC report from Working Group 1 estimates that globally, the aerosol are responsible for cooling down the planet by 1/3 of the amount that is being heated up by greenhouse gases. And that's a very important issue. First, because the aerosol particles have a very short lifetime in the atmosphere, of a few days to a few weeks. So any change in the aerosol particles reflect very rapidly to the global temperature. Instead, greenhouse gases like CO2 have a lifetime of several thousand years, and methane have a lifetime of about 11 years, but the aerosols have a very short lifetime. So this means that the aerosols right now are masking 1/3 of the heat caused by greenhouse gases. And if you clean up our cities, for instance, changing our transportation fleet from burning diesel or gasoline that produces a lot of particles to the atmosphere by electrical vehicles, we will reduce in urban areas strongly the amount of particles. If you change the energy system from burning coal or oil by, let's say, aeolic or photovoltaic electricity generation, we will also emit much less particles. So what it means is that in the next few decades, we will see that the masking effects of aerosol will be strongly reduced, and this means this will accelerate global warming. So that's another important issue in the global climate change arena.
And it was this issue, if I understand correctly, that inspired the famous Nobel Prize-winning scientist Paul Crutzen, who coined the term the Anthropocene, to suggest in an article in Climatic Change that you could introduce, I guess, artificially aerosols into the stratosphere to counter that effect of cleaning up aerosols lower down. Now, this idea has gained increasing attention of late, stratospheric aerosol injection, and may even be finding itself more in the spotlight given the lack of sufficient progress on emission cuts. In October, the US White House announced it was funding a 5-year research plan to look at solar radiation management, SRM, or as the IPCC calls it, solar radiation modification. Perhaps just to take a step back, what do you see as the current state of scientific knowledge about this potential technology, its risks, costs, and benefits? Where are we in our learning process about this idea?
Yeah, basically, science is looking for ways to give you options to the society to deal with the extremely danger of climate change if we do not reduce greenhouse gas emissions. And the science of the interactions between aerosols in the stratosphere with the solar radiation is still, let's say, on its infancy. So we know actually very little of the physics of the interactions between aerosols and radiation in the upper atmosphere. And there are a lot of new experiments designed to study better this effect. And these experiments are very important in case that we fail to reduce emissions and we enter in a climate emergency that could destroy the Earth's ecosystems, like the tropical forests, like the ice that are on the ice caps, both in the Arctic or the Antarctic. And science have to provide the society with the possible options. And one of them is solar radiation modification. But at the same time that you needed to understand better the process, we also needed to understand better the undesirable effects of such techniques. You know, they can be they can be dangerous to the climate system, and we needed to study better their possible impacts from the physical, biological, and chemical point of view.
And I guess those impacts would vary in their expression at local, regional levels, right? You'd have the global temperature impact but varying impacts at the local level. Now, as people can start to consider and do science on this, but also as policymakers start to engage on it, the key question is how to assess risk and how to measure the risks of of SRM and pit them against the risks of a warmer world without SRM. How does one actually go about doing that in practice? It seems just extremely difficult assessment to make. What does one do?
Yes, you is right. It's extremely difficult assessment to be done. You know, I remember 2 decades ago, you know, James Lovelock, you know, the person who elaborated the Gaia hypothesis, was advocating that he saw that the danger of allowing the planet to heat up by 3 to 40 degrees was so big that he was defending to build up, let's say, hundreds of nuclear power plants, you know, worldwide, to avoid a catastrophic failure of the global ecosystems, you know. Of course, nuclear energy has its own problems, you know, with the proliferation, with the residuals from the nuclear reactors, but it's just to give an idea of the kind of options that some people were thinking about actually 20 years ago. So now the situation is even, let's say, more dangerous for the whole society. You know, we are really, really not reducing emissions. You know, the governments are completely controlled by the energy and fossil fuel industry that it does not want to reduce emissions, even if they can put the whole 8 billion people and all the life on our planet in very difficult situation right in the next decades. We're not talking anymore on climate change for the end of this century. Actually, climate change is already with us right now, increasing climate extremes enormously and bringing important societal impacts for both developed and also developing countries right now. So the balance between action and the impacts is a very delicate issue that needs to be better discussed by the whole society.
One common objection or put out there or concern is that pursuing this research and then eventually questions about potential deployment, but could undermine efforts to cut and remove emissions, the so-called moral hazard. What are your views on that concern?
Yeah, no question about that. Any action that could delay the end of fossil fuel is actually very bad for the whole planet. So actually the only way that you can avoid a catastrophic failure of the Earth's ecosystem is basically to change the whole society to clean energy generation, to less consumption, and many other systemic change that you have to do very urgently. Actually, science have warned the society since the Stockholm Conference in 1972. That was 50 years ago. Science is warning the society, you are going in the wrong direction. You is not building up sustainability in our planet. You is tracking to a very dangerous situation. And then there was the Rio 92 conference that was actually already 30 years ago. You know, the same message was that. And then we had the 27 copies so far with the absolutely no reduction done in terms of global emissions. The global emissions are still growing up this year by 1.2%, according to the Global Carbon Project, instead of being reduced by 7% a year, as required by the IPCC 1.5 degrees report. So basically, the society driven by the fossil fuel industry and the deforestation industry is going in the wrong direction, unfortunately.
So with regards to that, that's happening with or without, as it were, a discussion or research in SRM. Do you think that doing research and discussing SRM makes it less likely, as the moral hazard argument goes, that the necessary reductions are taken, or does it not affect it at all?
I don't think that just doing research and not starting doing deployment, that are completely different things. Doing research on possible ways on how the society could get rid of this dangerous situation does not directly, of course, impact in terms of fossil fuel emissions. I don't think that doing research, increasing the knowledge for this society on possible options for next generation does not harm in terms of fossil fuel emissions, because actually, in my opinion, any of the solar radiation modification strategy could have also per se dangerous environmental consequences. But this needs to be quantified, this needs to be properly studied, and this is what you have to do right now.
Another critique, which some people hold very dear to them, hold strongly, is that SRM is a techno fix to a problem that's actually rooted in unsustainable human behavior and falling out of sync with nature. And there's a critique that says you don't start messing with nature. Why are we looking at this? I mean, you've got an interest in SRM. You've also got a great interest in nature. So how do you see the sort of relationship between this kind of technology and a respect for nature, and how, can these two be held at the same time?
Yeah, no question that the ideal situation, we could not even think about solar radiation modification. Point. That is very, very clear. If we would be an intelligent being in our planet, we do not even could consider that. But of course, we are already doing geoengineering the climate, releasing 42 billion tons of carbon every single year. So we are already doing solar radiation management through the emissions of fossil fuels. So basically, but the industry does not recognize that, of course, is not on their economic interest or political interest. But of course, the two things are science have to advance and finding ways of alternatives to this society in case society decides to use solar radiation management in the future, or if this becomes absolutely necessary, and that is a real possibility because of the control of the governments in our planet by the energy industry that has a very short side hand. So basically, the industry just wanted to increase their profits in the next 2, 3, 5, or 10 years. Nobody's thinking on the global climate in 10, 20, or 50 years. So this is something that needs governance globally, and actually as soon as possible, we need to change this picture very much.
The global south would likely have the most to gain or to lose from SRM. To what extent do you see experts in the global south involved in research, discussion, taking part in the governance of SRM right now?
Oh, there are a tremendous gap in terms of knowledge from the developed countries to the global south, So it's extremely important that the global south be engaged in all possible future solutions for the climate crisis, including solar radiation management and other techniques that are being considered. Either direct air capture, either whatever, capture of CO2 by the oceans and so on. And especially, as you mentioned, the global south will be the most impacted by climate change. And certainly it's on their own interest to design a possible fix for the global climate. It could be a solar radiation management or could be any other strategy. And to work on increasing the knowledge on possible strategies for the society is critical for the global south also, you know. So that is a very important point. This needs a coherent global action from developed countries as well as developing countries.
What challenges do you see facing climate scientists in the global south getting more involved in the science of SRM and the governance? And what kind of measures could overcome some of those challenges?
Yeah, one of the major challenges is that many of the developing world has very critical needs in terms of feed your population, in terms of housing, in terms of providing water, in terms of providing electricity for your own population, you know. So their needs are much more basic, let's say, than thinking basics for today, let's say, you know, than thinking on climate in 10, 20, or 30 years. So that is the first point. Second point, the investment in science and technology in the global south is just a small fraction of the investment that is generally done in developed countries. So this means it's much more difficult to do science, you know, in a competitive way with the developed countries because of much lower budget and resources available, like supercomputers, like training personnel, like strong universities, strong research institutes, and so on. So unfortunately, you know, the developing countries have a long way into enter on this arena, but this means that we need to emphasize the role of the World Academy of Science, Academy of Sciences in developing countries in joining this important activity that is basically find ways for our society to minimize the potential impacts of climate change in our planet.
You were recently at a conference on SRM organized by the Inter-American Institute for Global Change Research in Jamaica. What were the kind of big themes? What were you hearing from the participants there?
Yeah, that was very interesting conference, yes. So the Inter-American Institute for Global Climate Change has solar radiation management in their scientific agenda because they see that Latin American countries and actually countries from the Americas itself needs to enhance science in this area. And one of the outcomes was very interesting because most of the countries are not really, let's say, worried about mitigation, and they are much more involved in adapting their societies to climate change. So if you ask, we asked, you know, all the countries that were present in the conference, how they would allocate resources in terms of solar radiation management, research, mitigation, or adaptation. So basically the answer for most of the countries is that they will put 80% in adaptation to climate change, 20% in mitigation, and virtually nothing in terms of solar radiation management research. So this means that the developing countries are really desperate to adapt their societies to climate change because the impacts they are seeing right now, today, in their society are very big, and they are really worried in the future in terms of water availability, yes, in terms of increasing climate extremes, and so on.
This is a tricky one, but is there any way in which solar radiation modification could be considered as a form of adaptation, or is it something different entirely?
Yeah, it's something different, you know, it's not an adaptation per se, Although, if it properly done, certainly could be one of the strategies that
Right.
the societies could use, let's say, in the second half of this century to mitigate the impacts of climate change. So in this sense, it could be viewed as a kind of adaptation, but of course, is not properly an adaptation strategy per se.
One last question on SRM. Which international fora do you think would be the most appropriate for its governance?
The first thing would be TWAS, the Third World Academy of Science, that now is the World Academy of Science. TWAS has started a climate change assessment group that is putting together scientists, especially from developing countries, into drive a common agenda for adaptation, mitigation, but with a view on developing countries. And this is very, very important, because, for instance, if you follow the development track from developed countries like North America or Europe, for Africa, Southeast Asia, or Latin America, we will be in very bad shape. So we needed to change the whole society. We needed to change the whole economy, economic growth ad infinitum in a planet with resources that are limited, only exist in the heads of economists. This does not have any background in science, So we need to promote actually decrease in development in order to fit our society in the limited natural resources we have in our planet. And developing countries have a critical role for that.
I'd like to end, if I may, on a more personal kind of note. I mean, some of the things you've said today, and really, if you go away and think about them, oh my goodness, it's really quite challenging to look and see where we're heading on climate, and also, as you say, this sort of continued failure by governments to take sufficient action. And yet, here you are doing this after so many decades, still full of energy. How do you keep motivated? How do you actually keep your sense of morale up as you deal with this very grim topic?
There is no other way. For instance, my main research area is about the Amazon, So now we have to find two things: how to implement the policies that are effective to reduce deforestation, and second, how to make regrowth of forest in degraded areas in Amazonia. And to do that properly, in an optimized way, you need science. If you leave this important issue just for, let's say, the landowners in Amazonia, this will not work out. So basically, we need the public policies that are based on science. And we are developing these public policies. They are available. And now we have to make pressure on politicians with the solid science, actually, to change the course of Amazonian deforestation, make recuperation of degraded areas a top priority for the new Brazilian government. And this have to do not just in Brazil, but all over tropical countries: Congo, Indonesia, Paraguay, Bolivia, and so on. And of course, in terms of personal motivation, that is what drives my research, is to help society and make alternatives in terms of science for the very best public policy to minimize the suffering of our population. So I think that is personally is an obligation as a human being.
Well, on that note, thank you so much, Paulo Artaxo, for your contribution, and thank you for being a guest on C2GTalk.
Okay, thank you very much. It's always a pleasure to talk with you.